Giving gifts can be tough. I bought this beautiful hand-painted mug on my last trip. I brought it back to my family. I had one for each of them. And then I noticed they were never drinking coffee out of them. They became my mugs. It went fine. Hey, it's time for the Nerd Log. Thank you so much for joining us. We're going to talk about a really cool new feature, and one that not only do I like, but actually, like, I saw it in rehearsal, Ty, and then I actually used it on a demo like that evening with a customer. So it's that good. We're going to be talking about distributed tracing with Ty. Ty, say hi to the people. Tell them what you do for New Relic.
Hey everyone, I'm Ty Herbert. I'm the product manager for distributed tracing. I've also been New Relic for a while. I was the product manager for browser product, and synthetics, and the New Relic mobile app. In case you didn't know, we have mobile apps. Download them now. Check them out.
Yeah, and what we're going to be looking at is mainly around this concept of distributed tracing. So I want to take a minute and talk about like what it is. It is definitely when I started back in 2019, I thought that distributed tracing was like our clever name for it. But then I showed up at Open Telemetry Day, and everyone was talking about distributed tracing. I was like, these people don't love New Relic. What's going on? And I was like, oh no, this is just a concept. So help us define this term, distributed tracing.
Yeah. So think about the changes that have gone on in the last couple of years in technology, right? From our customer base, from a New Relic standpoint as well, right? We're going from all of these larger monoliths or server-hosted platforms to now microservices that are distributed all around the world, right? Multiple regions potentially.
Yeah.
So how do you understand how a request, when one button is clicked or when one API is called, all of the dependent downstream things that occur for that to happen?
Yeah. So
that's distributed tracing.
Like in the history of observability or monitoring, whatever, the trace used to be kind of your absolute like best thing, right? Everything that's on the call stack, every little time span, maybe every environment variable that was available, really, really detailed. Essentially, the equivalent of hitting break on the server and just saying, hey, show me everything that's going on, maybe even everything in memory, right? And so our ability to show you traces in New Relic was like, that was it, right? Now you had to know at least about that one request, right? There's a certain issue with you're kind of zooming in so far that you may miss the forest for the trees, but at least you have for that request. These days, that usually doesn't really cut it, because very often you're looking at, when you look at something like a serverless function, which is my home base, look me up on Twitter at serverless mom, is you're saying, hey, okay, it got a request at this time, did whatever code it did to it, and then tossed it off somewhere. It got a response from a database of some kind. It called the DynamoDB method, right? And the question is like, okay, well, what table did it call? And the DynamoDB put item took a long time to come back. Why, right? Like, what did that look like to DynamoDB? Why did it take so long? So that doesn't even capture the sort of normal course of events these days, which is several little serverless functions, other tiny pieces of compute passing a request back and forth. You get a trace for one of them. That really doesn't tell you, it just tells you one little frame of what is this whole movie. So distributed tracing is the future, right? You must be able to say, you see the request pass between multiple components and be able to tie them together. And so it's not a New Relic thing. It's something that the Open Telemetry people are working on, how to implement some kind of distributed tracing in from an open standard. And this is kind of our take on it. So Ty, what do you want to show us?
Yeah, I also want to just add to what you're mentioning is that if you think about it, that's just one trace, one request. Your example of going to the database, understanding the put request, but how do you measure that at scale, right, across time and over time? So that's where what we've been focusing on is how do we find traces that are relevant to you? So with New Relic, this is our distributed trace UI. If you haven't seen it, please check it out in your account if you have distributed trace enabled. If you don't have distributed tracing turned on, hit up our doc site or our support team. Let's get it set up because you're missing some valuable information here. So I wanted to show, this is the previous UI. So we've done some changes. One thing what we did here is on the left side, we added new filters. So what's the point of this? We really want to make it so that any user can go here and find their stuff, right? So we're adding the option to filter by entities. So essentially your app, your service, what you might be looking at specifically, or workloads. So workloads is a concept that we've created that allows you to actually group together entities that are important to you. That could be maybe a front end, an app, and then like infra agent or infrastructure that you want to monitor your team's responsible for, or it could be like the infrastructure or the entities that are required for a key transaction to take place. It really depends on how you want to group those. So a workload in this case is a group of entities, more than one. So if you say, hey, I have a workload, I just want to select that, and you'll see the traces related to your information there. In addition to that, we added the option to filter by errors. So a lot of times the feedback we heard was, hey, you know what, I'm looking at one error. I want to research and understand how this error is occurring in my system. There's no better way than through distributed tracing to see how that error is, like what's upstream and what's downstream of that error, what's causing it to occur.
Talk about forest for the trees, right? When you're looking at a single trace, it's pretty easy to be like, well, that's just the one time, right? You really don't know. Very common thing is you'll find yourself looking at a trace really deeply. After 20 minutes of clicking around, you realize, oh, that's some admin behavior. That's like, someone in admin was trying to impersonate someone else who has impersonate disabled. It's an error. It's super interesting. It's got a crazy stack trace, but it's actually not even a single user, much less representative of our phones are ringing off the hook right now, so that trace is not right. So being able to filter by like generally what was the error message is really, really powerful, because of course you have other tools to look at average performance, but trying to group together traces is really, really key, because if you're scrolling down and saying, hey, all 10 of these look really similar, now you're kind of looking at a pattern.
You got it. Yeah, and you actually went one step ahead. So I wanted to also talk about grouping traces. So to your point about looking at things by one trace individually, this is the list that we have that shows you every single trace that was captured for your accounts. We've added this option now to group similar traces, which gives you the ability to group traces by the root entry span. So what that does is it groups things by where it started. So it might vary downstream. There might be some requests or traces that have multiple entities that go through. Some of them might stop at the first or second one. So it's really more of a direction to understand, like, okay, instead of looking at all of these traces, here's the ones that are really interesting to me based on where they began and some of their diagnostic and characteristics. So for here, let me scroll down a couple here. You can see the number of errors and the duration over time. So this goes to the point of like, hey, I'm looking at one specific trace, but really, how did that change? How did the footprint of this traces that started from this post request over time, what's their duration changes? And also, were there errors, or was there a spike in error that occurred? And we've added the ability to compare the current trace group to like the last hour, day, or 3 days ago, to give you, again, some additional baselining to say, okay, the duration currently is here, but what was it 3 days ago? Was it lower? Was it higher? Like, is there something here that I need to look more into? In addition to that, when you click on or select a trace group, and I'm going to jump over here, I wanted to show that this is available both when you go to explore and distributed traces, or right here, sorry, traces, and this is, I have to go to the homepage to show the right way. Here, let me do it right. Browse data, traces, or when you're in an APM or an specific entity, if you click on distributed traces when it's enabled, you'll be able to see the same thing on an entity specifically. We're taking away the errors and workloads because you're already looking at one entity. You found the entity you want, you're on that entity. So it's really just by filtering by errors that's available. So I'm going to jump into one down here. Actually, I have an example here where if you select a trace, you'll then go to this scatter plot view, which is the standard kind of normal view that we've always used to help you diagnose which individual trace you want to look at. But then from there, I'm actually going to filter and show traces with a couple of errors here. So when I click on a trace, we also introduced a new feature now called trace maps, and this is available to everybody. This shows up when you have more than one entity. So if you're looking at a trace with a single entity, you won't see this, just a heads up. But this allows you to look at traces in a different way. So our traditional way was to show you a more like waterfall time span series view into this. But with a map, you're able to actually visualize this in a different way to say, hey, this request went across these entities. Here's the number of calls that have been made between those entities. But then also some additional information about the specific entities. For example, this one's red, indicating that there's an error. You can see that here, but also by hovering over this. But when you hover over, you're able to see, let's see if I can do it, the different dependent things for that entity. So for example, this one has this many hosts hosted on this, or it's within the host that it's using. Oh, sorry, losing some screen space here. But when you select it, you can also go down and understand, okay, this specific entity is in 12 workloads. So this related entity section, if you haven't checked this out, is very, very helpful, very cool. But it shows you the number of like synthetics monitors that are calling the entity, the number of services that it's called by one service. So it's caller, callee, like directionally, what is dependent on this entity specifically. So for example, in this one, you can understand that where it's called by one service, that's green, but then some of the workloads related to this are red. So it gives you kind of a direction to say, okay, well, this is an error here. Is that error impacting someone else? Or is it also causing an error based on another request that's coming into this entity from a different direction that might be causing the error to occur?
Yeah, something that I love most about this map is, this data. This data is stuff that was available often in the trace already, right? Like you would have the multiple entities be listed as time chunks, but you didn't have that visual element to say, like, what is this telling you, right? What does this tell you about the direction of requirements? And also, this one, you of course look at the draw when we're looking at live data, has just a few nodes, but most of my serverless demos have, 4 or 5 different nodes involved in a single trace. And so that one is just harder to glean from a list.
Right. Yep. You got it.
Yeah, I think this is amazing because you can see exactly how a trace has originated and where it hits within your very complex system to really understand what might be going wrong if like a trace is taking forever. So I really think this view is amazing.
Yeah, and I think another thing to call out here, and this doesn't have an example of this, but I get a lot of questions actually about orphan spans. So requests where somewhere within that request, something's either not passing, monitored or not passing across the trace information for us to be able to connect it all together. So we're actually able to present orphan spans here as well as different requests, like where other requests that we see are connected, but they're not connected to the full stream. So it allows you to start understanding, like, how can I correct those? What is maybe the missing piece that I need to start monitoring to make that trace like fully connected in my system. Then one other thing, I guess I wanted to make sure to talk about too, if we're okay to go to the next shiny thing here, is infinite.
Yeah, no, I will just mention before we zoom on that this little mapping piece works now. So I just went to look at my like serverless demo and it was already up and running. And so, yeah, if you want to check it out, in your own account, just go take a look.
Correct. Yeah, it's available to everybody. And make sure, just the one caveat out there is that you have to select a trace that has more than one entity. If you only have one entity, it's not, obviously there's one entity, there's nothing really to show there. So that's why it's important.
Yeah, go to one where you have like EC2 and serverless Lambda hitting each other, and then you'll see it.
Yep. Go on. So infinite tracing. I wanted to talk just a little bit about head-based versus tail-based sampling. So I knew really from a tracing standpoint, there's 2 different methods of sampling, and they're quite different depending on what you need from a tracing standpoint, what you want to collect. The traditional way that we're demoing here is head-based sampling. So head-based sampling is where the agent essentially captures 10% of the traces that are captured and sends those off to New Relic to be displayed and captured here. So it's a more limited sampled view into your trace data, where tail-based sampling is a kind of a newer way to sample your data and give you as a customer more control around what traces are sampled. Instead of being at random 10%, we're going to be, what you do is you flip in your agent and you add a different configuration that sends all of the data to New Relic, or all of it to what we call the edge consumer. And you then set up business rules at the consumer to say, for my account, I want to find traces that match these criteria. You have the option right now to give 3 criteria with the ability then to say, based on those criteria, when things are met, give me a percentage or a random sampling of those traces. So this is all built on what we call New Relic Edge. New Relic Edge is a cell-based architecture, like a host that is in a AWS region. The goal of this is to have that data as close as possible to where you're hosting your data. So the goal there is to reduce the number of hops between your endpoint agents and our New Relic Edge, and also some of those change in fees around transverse fees between your endpoints and our endpoints. So with that, I'm going to go ahead and show you real quick where this lives. So if you click on, let's just go into, if I go into my New Relic homepage, and oops, here, I'm going to click on this apps. So it's essentially a NERLIT. So you go in as though you're going to get find a NERLIT. This is the New Relic Edge NERLIT. Just to also call out, this is only available to Pro and Enterprise accounts. So you need to be in a Pro and Enterprise pricing tier to have this available. When you open this up, then you have the option to define your infinite trace observer. So the trace observer is
wait, time. I spaced out for a second.
Yeah.
And that's on me. Okay, I have attention deficit disorder. Everyone who's watched this show knows it. So what is infinite tracing, though? What is infinite tracing, though?
What is infinite? So infinite tracing, that's a very good question. So infinite tracing to New Relic is tail-based sampling. So it's our ability for us to host a consumer that can get all of your data, all of your trace data, and then allow you to filter it down to the sample set of traces that you'd want to save. So New Relic infinite tracing is the way that we support tail-based sampling from a distributed tracing point of view.
So when we say tail-based tracing, what we're saying is, let me see if I got this. Okay,
Yeah.
you stop me if I.
Wait, I want to try it too.
Okay, Daniel's gonna do it. Daniel's gonna do it. Let's hype him up. Daniel.
No. Wait, don't
Daniel.
do that. I'm gonna get nervous. I'm gonna get anxiety.
All
Just
right.
like, but okay. So isn't
Let's hear what
tail-based
Daniel has to
sampling-
say, everyone. I don't think it'll be great, but let's find out.
Wow. Okay. Wow. Okay. But
There
like,
we go.
isn't it like tail-based sampling like a whale shark, just shoving in every single thing that comes through? And then it just like filters, like, so all the water that you don't want just gets filtered out and you just get to keep the ones you want. I feel like that metaphor is not approved by the marketing department. But isn't that what tail-based sampling is? It's just collecting everything and then filtering instead of head-based sampling, where it's basically like querying, like just like looking for anomalies and just collecting, saving the stuff that looks weird. Is that true?
Yes, the tail-based sampling analogy is great, by the way. That's amazing.
Okay.
Yes, yeah. So you're eating the traces you want as a whale shark. I love it. I'm going to use that going forward. But head-based sampling is like the water's filtered before it even goes to the shark's mouth with head-based sampling. Like the filtering takes place before it even like goes. So it's like the water that is sent in is what your head-based sampling rate is.
Yeah.
So-
And what'll bake your noodle about this, right, is that the thing about going from the head is obviously you don't know that a trace is interesting before it happens, right? You can add a few little things there where it's like, hey, this person's in from a geo we care about, right? They're in an area that we care about, or the URL they're hitting is interesting or something, right? They're making a purchase, right? So we really care about that transaction because it's the one that makes us money. But in general, right, a trace isn't interesting until after it's happened.
Right. Yep. It's the whole sampling problem that you run into in general, where how do you find that one specific some set of data that's important to you that doesn't occur all the time? So with head-based sampling, you might miss some of those spikes or those requests that are having errors, right? Where with tail-based sampling, you can define exactly what you want to see. So you're going to see those every time.
So I think that's a semi-success for me, you know.
Yeah, very solid, Daniel.
Thank you. I'm gonna pitch it to the marketing department to be like,
I think
can we sell this as a whale shark?
I think mine would have devolved into like timecube.org. I would have been like, you see, because every time there's more times. And if you cut that time, you're just gonna have time in your time, okay? The stream, the ocean refuses no river, and it would have fallen apart. Now we can talk about infinite tracing. Let's do it.
All right. Wait, what is infinite tracing now?
Okay.
Wait.
Okay. No. Oh no. Oh, I thought I had it. I had it, but I don't have it.
All right. It's tail-based sampling. So it's how we support tail-based sampling. It's the whale shark.
Okay.
We actually get a whale shark icon. That'd be great. I love it. So with infinite tracing, this page is where you go to set up and define those rules that you want to define for when to capture a trace. So again, with tail-based sampling, you're sending us 100% of those spans. We're looking at it here on the infinite tracing consumer, the tail-based sampling consumer, and we're going to then filter those down based on the rules that you define. This is, I just wanted to show where to find this. you go in, you create a new trace observer. You can select the region that's closest again to your infrastructure, your host, where things are that you want to collect traces from, and then you define those filters. So, for example, here is a couple of filters that you can define for infinite tracing. You then would need to grab that endpoint that's captured or that's provided to you, and you then update your agent configuration to then have your New Relic agent send data to infinite tracing, and then that's when the process starts.
Got it. So infinite tracing supporting tail-based tracing. So, but now we're talking about a trace observer, right? Oh, and that makes sense because we're getting everything, and then we're saying, hey, what do we want to keep? What do we want to throw away? And that's the trace observer, right?
You got it. Yep.
Yes. Yes. Can I get a W in chat? Yes. Love it. Let's go
Big
on.
W.
Yes. All right. I guess the other thing I just wanted to mention was that we also support mobile. So the New Relic mobile APM agent, when it's installed on your mobile app, we support traces that start from the mobile app now. So if you have distributed tracing enabled for your mobile agents, or if you don't, please check it out and see if that's something you're interested in doing. But you can, within the distributed tracing interface, will show you when a mobile span is present, right? It has a mobile app. We do the same thing with browser as well today, where you can see it's like a web page that triggered the trace. And that's really all the things I wanted to cover. I think I call the ability for both of you to explain tail-based sampling and infinite tracing.
Yeah, that's a pretty big win. Yeah, because unlike regex and querying, both of us have actually had like a practical reason to do that in the last couple of months. So this is just like we've been I'm just like excited to demo. But yeah, well, the nicest thing for me is how this changes the map a little bit for serverless. Right. And I even promote this thing as we have new serverless features to talk about. And I want us to get together. I think we're going to do a serverless episode of the Nerd Log soon, followed by a Kubernetes episode, because I think that while this is a general improvement, the way that it improves people who are in these really heavy microservice environments where they have a bunch of little tiny compute pieces flitting about, it really, really changes the game for them. And also, these are the people who I know every single one of them agrees I have an observability problem. Right? Like most people who are running, like 5 or 6 servers on various virtual machines and hosts, they're not saying like, I don't know what's going on with these hosts. They can still get surprised, right? But they wouldn't say, oh, I always have an observability problem. But most of the people running serverless absolutely do. So that means we gotta talk about them more.
All right.
The only thing I request for this episode is that all the PMs call you mother during the episode. Throughout the whole stream.
Yeah. We'll do it on Mother's Day next year. No, that's just too long. Too long. Too far away. We'll have to do Grandma's Day. So
Grandma's Day exists? Wait, what?
Probably. Okay. Hallmark's trying to make it happen. They're out there. They're like, only when there's a 5th Tuesday in this month do we have Grandma's Day. So, Ty, people can check, with the exception of infinite tracing, which is an enterprise feature, people can check this out today in distributed tracing.
Right. Yeah.
So we want people to just go in and try it out in the interface. What else do you want people to do? Do you want to plug your SoundCloud? Do you want people to follow you on TikTok? What is it that you like? You want some social media followers? What are your final plugs for this segment?
I would actually say more about to your last point about using this today. So this is available, but I think one of the challenges we see is a lot of our customers actually haven't enabled distributed tracing or don't know that it's available. It's actually an option. So now that you all understand the value that this can provide, I would ask let's get this enabled on your agents so you can actually start using these features. They're there, they're ready for you. We just need to make sure that data is being passed through the New Relic so we can present it in a way that's providing more value to what you're seeing today.
And in most cases, that's just a config that you're passing to the agent. It's not that you have to go in and edit your application code. You just have to configure the New Relic agent. Yeah.
I don't think you have to configure it. You have to turn a button on. It's very satisfying. There's a little toggle.
Oh, like within the New Relic UI?
Yeah.
For certain agents, if you're doing server-side config, you can do that. But mostly, generally, it's an agent config at this point. I think though down the road, that's also in the works. Some plans for us to help make it a lot easier to do it. Yeah, that's
Thank you for not letting me spread some fake news, because I remember when I was like configuring my app for distributed tracing, there was a little like button where you could just like press yes for distributed tracing, and it just all worked.
That is true for some agents. It's not not everyone yet, unfortunately.
Yeah. So this is also, I mean, there's going to be people out there. I know this, from personal experience, right? There's going to be people out there who are running an 8-year-old version of our, .NET agent or that kind of thing. Maybe this is the push you need to say, hey, I understand it's work. I'm not trying to downplay it. I mean, I understand that you have other responsibilities. Most people who are using New Relic do not, they're not the New Relic gal in their org, right? They have a bunch of other responsibilities. But I think some of these latest features are strong enough that I think you could argue that they're really worth your time, right? Look at some of your recent incidents. Ask if you really wish you could have seen in one click how that service that was failing or flapping or whatever was tied to your other services. And I think maybe this is a motivator to do that agent update. You've been getting the emails from us. It may be time.
You got it. Exactly. Yep.
All right, folks. I love our audience so much. I love the people who come out to see our streams. It's the hundreds of you who are watching on YouTube. It is just fantastic. I mean, we're getting on to 6 months we've been doing the Nerd Blog, and it's taken off so much. It's been so fun, and we keep expanding it. Datadog tried to do a version of this. It was
wait. Let's not talk about that. Let's not bring other folks.
Hey, let's not get into that. We don't.
Let's not. Let's not.
In all seriousness, folks, it's been such a great adventure doing the Nerd Log with y'all, and I super duper appreciate it. If you get a chance, follow me on Twitter at Serverless Mom. Follow Daniel at LearnWDaniel or Learn with Daniel. That's the way you remember it on Twitter. Check out Bit Project. Check out Serverless Day Student Edition. You'll see some links in the YouTube description down below. Daniel, other stuff we're supposed to be plugging?
Yeah, so I think we're gonna add a verse in our observability rap song about distributed tracing and especially tail-based sampling. So make sure you're on the lookout. Maybe like once we hit a certain view milestone, me and Nika, when she comes to San Francisco, we can rent a studio and record a rap together.
I won't do that because it's cultural appropriation, but I will do something else. I will auto-tune myself into doing something. I will make this keyboard actually play something and won't just have it as background art. Okay, folks, thank you so much for joining us. We're going to call it there. It's been an amazing hour and a half. And thanks for keeping up with the Nerd Blog. We'll be back every Thursday.